Hello, Rochelle here, and the purpose of this video is to talk about graphing and rewriting inequalities, in particular linear inequalities. So an inequality is pretty much just, oh, I thought that was going to be a highlighter. It's just something that looks like this. We deal with them all the time, and we need to be able to read it. This one says x is greater than or equal to 2. That line underneath means that it could also be equal to. So the first thing we're going to do is we're going to review how to graph that on a number line. So first of all, we need to somehow label our number line, put some kind of scale on it. So we know that if each of the tick marks is 1 or 2 or 4, we're using 2. And so greater than or equal to 2, that means that we're going to be going off to the right, numbers that are bigger than that. And so there's two ways that we can put this as an end here. Sometimes you'll see them as filled in circles, and sometimes you'll see them written with brackets. We're going to focus on the bracket. I like to think of it as, well, since it has a straight line here and it has a straight line here, those match. Whereas if it was not including, like this second one that says x is less than -3, so you'll notice that we have our number line. We should label that x. We have our -3. We're looking for all numbers that are less than -3. So that's going to be like -5 and so on. So that's going to go off to the left. And instead of a bracket, we're going to use a parenthesis. Sometimes you'll see that listed with an open circle. So those are two different ways to label the same things. If we have an x that is in between two values, then we're not going to have an arrow at one end. Since this is greater than or equal to -7, we're going to put a bracket here because we're going this way. But it's less than 5, so we're going to have a parenthesis right here. And that's how we would graph it. And lastly, if we're less than or equal to 4.5, this could have also been written as 9/2. I usually suggest that people rewrite that as a decimal in order to find it on the number line. I find it right about here, and we're less than that number. So an example would be 0 is less than that number, which is over here. So that means that my graph is going to go this way, and we're going to have a bracket because it's less than or equal to. Now, also, we are very interested in rewriting inequalities. This is called an inequality notation, this notation that we have right here. We want to also be able to write it in interval notation. And this table kind of shows us all the different interval notations that you can see. But basically, you're going to have two numbers that are separated by a comma, and then you're either going to have a parenthesis or a bracket around it. So it could look like two parentheses, it could be two brackets, it could be one parenthesis and a bracket. And I'm just writing the number symbol because there could be a number, there could also be an infinity. Now, remember this, whoa, that was cool. I have no idea what I did to do that, but that was nifty. This symbol is going to mean less than. Okay. Now the numbers on the left, so all the numbers that we're looking at on the left-hand side, those are all going to be my smallest value, my smallest number in my interval. And the numbers on the right, these are going to be the largest numbers on my interval. So when I look at this graph, so let's say I'm looking at this graph right here. My smallest value is the value that's going to be furthest left. So that's going to be the number that goes on the left. And I'm just going to match that graph, that parenthesis. Now, if the graph goes on forever in either direction, it goes on to infinity. Infinities to the right and negative infinities to the left. So instead of writing, greater than or anything, we're always going to put an infinity symbol. And that's always going to have a parenthesis because there's no number that is equal to infinity. Because for every number you give me, I can give you one larger, then you could give me one larger, and so on and so forth. We can never reach the biggest number. So we're going to try and rewrite the first examples with interval notation. So let's go ahead and look at this first example. I think it is easiest to graph or to imagine a graph if I want to go straight from x is greater than or equal to 2. Oftentimes I visualize this graph first, because if I look at it to the leftmost number or the smallest number is going to be 2, and there's a bracket on it. And then I see this arrow. This arrow means forever, right? And the way we're going to write forever is infinity. Looks like a sideways 8. And that's just going to be a parenthesis. So again, sometimes people see this arrow like this. As long as the X is written on the left, they see, well, that's going off to infinity. I pretty much just like to visualize the graph, because then I can rewrite it right underneath it. This is my biggest value. It's the one furthest to the right. So I'm just going to put a parenthesis on the right. The arrow is going to require a parenthesis. I'm going to copy my rightmost number down here. And then since this goes on forever to the left, oops, I can't write right there. That's going to be negative infinity. Similarly here, I could rewrite this one right underneath it. My left-handmost number is 7 and my right-handmost number is 5. Now I probably want to bring those a little bit closer together. Same thing here. If I looked at it, the furthest number to the right is 4.5, and then it goes off to negative infinity to the left. And so that's going to be my left number. Now we'll look at just a few more examples to make sure that we can do it. So again, x is greater than negative 4. So if I want to just go from here, I have to decide, is negative 4 my smallest number or my biggest number? So x is bigger than that value. So that's going to be my smallest number or my left number. Again, if you're not sure, just draw a quick number line. Oh gosh, look at, I put negative 4 on the right. Wow, that's a little bit crazy. This says bigger than, so that means it's going to go off to the right. It's not equal to, so I'm going to put a parenthesis. Only the brackety thing if it's equal to. So that means if I did it right underneath here, negative 4 would be my left-hand number, and that arrow basically implies a infinity symbol because it goes forever, and it's going in the positive direction, so this will be positive infinity. This one's a little bit tricky because it's written a different way. It says 6 is greater than or equal to x. So the best thing we can do in this case is to switch this around. When we switch it around, do you see how the alligator, I learned that this was an alligator, is eating the 6? That means that when we switch it around, the inequality also needs to switch around, so the alligator is still eating that 6. Now I can read this a little bit more clearly. It's x is less than or equal to 6. So if I imagine my number line, that's going to go off to the left, and it's going to be a bracket. So that is just going to be 6. And then that arrow means infinity, but it's to the negative direction. So it'll be negative infinity. So I don't know if you see it, but a graph is very helpful. I always visualize a graph. Here I'm going to flip these around again. So that's going to be y is greater than negative 10. Negative 10 would be somewhere here. I'm going to go off to the right because it's bigger than. So this is what my interval notation is going to look like. Most of the ones that we deal with have an infinity. We don't deal with as many that go in between two values, but that actually, since it's between two values, 6 is the biggest and negative 2 is the smallest. Then I'm going to use a bracket because this is less than or equal to, and a parenthesis. Again, we could have graphed it first. So, whoops. I'm going to stop recording.